All right, the next bit is integral calculus, antidifferentiation.
We started
Chapter 11.
I thought we started on Monday.
Yeah. Today's Tuesday.
That was last week. Alright,
All right. So first of all, area under a graph.
oh, this shit. I was looking at this in the book and it looks so. Is this the one where it has like this, like this square, like columns, and then there's like from this side? This looks really bad.
No, it's not.
Pretty much the same, yeah.
Have you seen like
That's the area under the graph.
That's what it's supposed to say, yes. Let me move my axe up to. How's that? Is that better?
Is this a new thing? Yes.
It's part of the calculus.
So if you're like me, you haven't finished up the 10 yet.
Like 4 little things. Yeah.
I cannot get out of the way. I've tried so hard.
It's hard. I'm just like,
So much weight into
You were
it.
playing.
I spent literally hours trying to catch up on
No, I
it.
said, have you? Did you do your
We're
warm
gonna
ups?
fail my check.
I got a room.
Em was just having a bit of a
Reading both my
She was having
zeros
a
and my loss.
Emily.
Would say this. Yeah.
You can tell me about it after we like. You love it.
All right, so
While she was sleeping. Yeah, exactly.
not a huge amount of detail, but just enough background hopefully to get the idea. All right, so these two graphs are the same, believe it or not. So if we want to find this area, what we can do is we can approximate the area under the graph by creating some rectangles. So we can create some rectangles like this. Alright, so some little rectangles are here. This corner touches the graph. So our area would be approximated by the area of those three rectangles. Now quite clearly it's a little bit short because you've got these bits up here. Now alternatively we could create some other rectangles. It would be like this. And again, the area of those rectangles approximates the area underneath the curve, and quite clearly that's a bit too much because we've got these bits up here. So the actual area is going to be somewhere in between these two things. Alright, a couple of definitions. So these ones on the left here are called left rectangles because the left-hand edge of the rectangle, the left-hand edge, this one here, the left-hand edge of this rectangle that touches the curve. So these are called left rectangles. Because the left edge touches the curve. Can't spell. And so the area, of course, is the sum of the areas. I'll put that.
What the fuck did I just draw?
No clue, Glenn.
Oh, Karen's on.
Alright, so the area is the sum of the areas of the rectangles. Alright, now mathematically it looks like this. The area
Thank you.
is equal to B minus A over N. I'll get to that, what that means in a minute. Sum I equals 0 to N minus 1 of
Sorry, what?
f of xi. It's f of x. So what does that mean? What does this mean?
What's that? What's this?
That's the
Yeah.
weird thing. Look in your book, it's this weird thing.
Alright, so what does all this stuff in here mean? B minus A
Maybe I should bring the book.
over N.
What was that school?
So B
Yeah.
minus A is this distance
I can brush it.
over N. N is the number of rectangles you've got.
Oh, okay.
So here I've got 3 rectangles.
No.
So the B minus A over N tells us how wide the rectangle is. Alright, so that's the width of our rectangle. So this bit here,
I actually don't know.
width of rectangle.
What's the Z looking?
Or is it a 2?
Signal.
Sigma.
It means something.
It's, yeah, I haven't drawn it very well.
Yeah, that's not it.
What is the relationship between B minus A on N and
Yeah,
the
that was not it at all.
next equation? Are they like
Alright, so this is times in here.
times? Okay. Just checking.
This is times in here. So this is the width. So if we want to know the area of that, it's going to be length by width, doesn't it?
Yep.
So the width is this bit, and the length is this bit. So if we f of up that point there is A and f of A, and the f of A bit is that length. So this bit here is the width. So what does this mean? This means just add them all up. So we've got the length times the width, add them up, and then we get the area.
Wait, so what's N again?
N
N
is,
is how many
yeah, so N
rectangles
is
you
the
have.
number of rectangles.
In the book it's not. Sometimes.
Both N's equal the number.
So N is the number of rectangles. So in this case, N would be 3 because we've got 3 rectangles.
What
But
about
like on both ends.
Yeah.
N over, is that in minus
So we
1?
start here, in this case, because the left-hand edge, so we start at here and we finish there, not over here. So we're finishing before any rectangles and we're finishing at the end of the second rectangle. Alright, so in this bit here is our length of our rectangle. And the bit in the middle just means, in this bit says add them up, add all your rectangles.
And that f of x, is that another times or is that
The f of x, yeah,
in terms of that sum? Whereas what's that doing in that sum? In that equation?
actually in that, then what you do is you do this. There's a bracket around all of that that's left out.
Okay.
Is that N minus 1 over
N minus 1, yes. N minus 1. So here, because it's this edge we want, if you think of N as the rectangle, so if when we start here, we haven't had any rectangles yet. We get to there, there's 1 rectangle, here there's 2 rectangles, here there'd be 3 rectangles, but the edge we want is this one here. So it's the end of the second rectangle, so that's why N minus 1.
And why is the I there next?
The I is just which rectangle, which one of these it is.
Right.
Wait, is it the I next to the X?
So that's I0, I1, I2, I3, and so on.
Wait, so that is an I next to the X.
That's an I there, that's an I there, yep. So I equals 0 means we're using this x value to find that length, I equals 1 is using that x value to find that length, and I equals 2 that and find that length.
Okay.
All right, but basically mathematically that's what it looks like. What does it mean? It just means length times width, length times width, length times width, add them up.
Okay, I see.
All right,
I'd love an example.
we'll get to an example. It's an example right there.
Very nice.
All right, so these ones here, because very similar, they're right rectangles, aren't they? Because the right-hand edge. Okay, so our right edge touches the curve. Again, the area is the sum of our rectangles.
Did they get a tattoo?
Yeah.
What?
Set it for a little while.
And so mathematically, it's B minus A on N again, the width.
Someone told me that.
No, it's just being.
I'm sure it's on his face. I can't see him.
Someone, the person told me that.
Now this time, so that we know the difference of whether we're using this edge or this edge, we now don't start with this x value,
Oh no, we're starting with the.
because we're going to start with this x value here, because these are right rectangles. It's the right hand edge, so it's this x value we need to start, and if that was x value 0, this one's x value 1, and then of course we need the last one, the third one, which is n up there, and so that's just f of x I again. Alright, so mathematically when we look putting it in that form, it looks very similar. Again, it's just the same. The length times the width, the length times the width, the length times the width, add them up. All right, the actual area is going to be somewhere in between those two. And the more rectangles that you make, the closer you're going to be to the actual value. The more rectangles you make, the smaller this area here that you're short, or the smaller this area here that you're too big.
That's t equals 1 and then x beyond.
Where I.
Seems like.
It'd be more accurate to do break with them and then have an average of between them.
You can do that, yep.
Or you can just.
I hate this. The whole of method is like show
Most
exact value, show precise answer. And it's like, can you generally tell us like somewhere what would be near the area? Like if you want, maybe I don't know. It's up to you.
We are moving to getting precise answers, Clint. We need
Yeah, because it might turn
to
out.
we need to work through the theory of it. So it's like when I did that derivative bit and we looked at the gradient of the line joining those and we moved that down and got closer and closer. So this is kind of the same idea. So we're using some rectangles, we're approximating, and we're going to bring it down and we're going to get closer and closer, and then we're going to find out a way that we can
Precise.
precisely do it. All right. So the actual areas in between, smaller the rectangles, the closer to the actual area. Now the other thing sometimes I've used left and right. but alternatively, sometimes upper and lower. Upper because these are above the line, lower because these are below. The study design mentions left and right rectangles, so that's why I use left and right, but if you read upper and lower, upper is it above the line, lower below the line. Alright, and I'll rub all of that out.
Yes.
Please do. Are you finished?
Somebody's put something on the board that they shouldn't have.
Why do we need to learn this one?
You're able to sharpen it. I need this one myself.
I don't know.
I don't.
Maybe
What is it?
it might be working.
Cybersecurity and criminology.
Why can't you injure some of their players?
It is.
He was so angry on the league. I was like, calm
The
down,
dude I
bro.
was talking with it today, he was,
Yeah, well,
yeah, they literally just,
basically
they
kicking
go off
it.
campus
Yeah, I know.
and they actually do this and just,
Someone's wrecked my board.
they just on the
Ajax, I bet you that's what you're on there.
Shame.
What's wrong with it, Mr. Senate?
I was talking to my mum.
Leaving marks all over it.
Somebody put something on the board they shouldn't have put on the board. Can't get it off.
So, that's
Unbelievable.
Right.
Still get through, I'm sure.
Right, so let me write that. What I said, the actual area is in between.
so there is aliens. Human blood's red. And dry is brown. And has black.
This is just really
It's also marker.
Hey, she's your sister, no?
Ethan, maybe the person like died from hypoxia or
Hypoxia.
hypoxia. Yeah, like hypoxia.
More
I
rectangles,
think that would make your
the
blood.
closer you'll be.
It'd make it darker.
As
It would make it black.
soon as your blood is exploded, like, it doesn't matter if you get cut on your vein or whatever, your blood doesn't come out blood because it comes out to the air again. It's
It's
just
got
exploded.
Because
Yeah.
it's oxygen.
Yeah, I never even thought of that.
Sometimes they're called upper and lower.
Drive me back.
This room is a vacuum.
Yo, if you died in space and you went all cold and then you landed on Earth, the blood would be
No.
yes.
Do you realise space has dirty too?
You burn up on the
There's no
oxygen.
you about oxygen. Oh.
Why can't I burn without oxygen?
Maybe you should.
I feel like that's,
I'm just gonna go home and cover it. Why do?
I'm so confused.
The physics didn't get there.
Common sense says no.
All right, now the other thing that I haven't mentioned, this area, the area under the curve, is referred to as a definite integral.
Common sense is
What's
that?
I think physics says good well, actually.
Physics says
Which is always good, isn't it? Like,
It's not that much. Yeah.
And it's written,
hey Glenn, do you like this one? Okay.
I got a big boy.
No, it's not
you
nice.
should start wearing a bun.
So I'm thinking about
You
these.
should not.
Oh, there's that, there's that.
You should,
March of that.
That is
Mine.
building.
Are you implying
Shocking. It's so bad.
Yeah.
In 2 more years, no hair.
Yeah, your hairline will run away.
Not that simple.
I'm gonna have the racing stripes.
That looks nice.
Glenn?
Just receding
Just
hair.
writing stuff down.
Thanks, Mum.
right, so that's what I just talked about, the actual areas between the left and right, more rectangles closer to the actual, sometimes they're called upper and lower, and this area is referred to as a definite integral, and it's written like this. So the area between A and B, underneath the curve, fx dx, is what's referred to as the definite integral. So now we're going to develop and look at a way that we can calculate this definite, well, not now, today, but in the next week or so, how we can actually calculate that. However, because there's left and right rectangles in the study design, we need to be able to do that as well. Let's do an example.
Is that just fx dx?
fx dx. So fx is the equation of the curve.
Because the word is just not
The bat. The thing.
I'm just curious. Curiosity.
You right this
Alright, can I rub that off?
Yep.
Alright, a couple of examples.
The sideburns looking like.
Yeah, they are alright.
The sideburns should be changed.
They look like Jack Allen.
I think you should get a new mullet.
Yeah.
I'm not going to shave until after lunch.
No, you're not coming if you don't shave.
Don't get a shaved mullet because it just get like a just shave the
No, I mean
sides.
like shave my beard. You could get a
Yeah, thanks for that.
for the white thing.
That sounds awful.
My
Okay, you can start now.
you have to say these things.
No, I don't want you to know. I reckon you probably kill a mullet, Z.
Is there a full stop?
Yeah,
Oh,
like,
it's
like
common.
I'll put them wherever you like.
not like a
Lara.
feral mullet, but like a luscious.
Yeah.
What
You
you said?
shave the sides.
Full stops and
Yeah,
commas
okay.
and
It looks like
semicolons
a-
and things are not my, they're not my strong point.
There you go.
Very-
So if you feel that you need one in some place, then go right
Heck
ahead.
yes, here's go to Lara's.
Bring
Probably.
clippers and we can cut each other's hair.
No.
Then if you don't
Z, you remember the last time someone drunk cut your hair?
have to stay there.
Better than scissors.
You know what someone come
Just
up with
remember
as an idea if we win the grand final this year?
What?
We're going to play haircut roulette. So you put your name in like a hat.
Oh,
If you put out someone's name, you get to give them a haircut.
We're not playing that game at
That'd be
that
pretty
time.
full on.
Mate. I feel safe. We're going to get one. I feel safe.
Alright, looking at the question, it says find the area of the region enclosed by the graph of fx equals negative e to the x-axis, and the lines x equals 3 and x equals 4 using 4 left rectangles. So, first of all, let's do a bit of a sketch. So, what's the graph of negative e to the x look like?
Kind of like those ones that you drew before.
Kind of like the ones I used before, except
negative.
negative. So,
Stand down.
negative 1 down there,
We-
and so it goes like that. X equals 3 and x equals 5 it should be, not 4, sorry.
Oh.
So 3 is here, 5 is here.
Oh, exactly.
So what it means is find out this area. And it says using 4 left rectangles. So 4 left rectangles, so if I divide that in half and in half again, there's 4 bits. Left rectangles, so the left rectangles, the left-hand edge touches the line. So the left-hand edge touches the line, so there's one rectangle, there's another, there's another, there's another. Alright, so split it into your 4 columns that are going to end up being your rectangles first, then wherever those lines touch the left-hand edge is where your rectangles. So we've got these 4 rectangles and we need to know the area. So if that's 3 and that's 5, then halfway between them there has got to be 4. And in here's got to be 3.5 and here's got to be 4.5. So the width of our rectangles is
1.5.
0.5. And that's always 0.5. What changes is the length of our rectangles. So the length of this rectangle, let me use this here. So this length here depends on 2 things. The x value and the curve. So that length there, this length, is f of 3, which is negative e to the 3. And then the next one down, this length here, this red length, is f of 3.5, which is negative e to the 3.5, and so on. So the areas then will be our lengths by our widths, our lengths by our width, the length by our width. So the area then, we need to add up length by the width, so 0.5 times negative e to the 3. To that we add the next one, which is 0.5 by negative e to the 3.5. The next one is the x value of 4, so that's plus 0.5 times negative e to the 4. And then I've run out of space. And 0.5 times negative e to the 4.5. And we stop there because our last rectangle, this is the length we need, which corresponds to x equals 4.5. And then something like this, you would need to follow the directions of the question, but if you work it out in decimals, you get negative 98.91. So we've got a negative area.
That's unfortunate.
It is unfortunate. Can anyone identify what that negative might represent? Because it's below the graph. Yeah, the area's down here, so that's what the negative tells us. Tells us that that's under the x-axis. And because, as Glenn said, negative areas is very unfortunate, what we do is we recognise that the negative means it's under the x-axis. The actual area itself is 98.91 square units. Alright, so we ignore the negative because it just means it's underneath. And later down the track we'll get to how we deal with that. More complicated.
Would you ever not be given units?
It's quite often that you're not given units, so you'll just write square units.
If you aren't given units,
You just write square units,
the unit marked down if you don't write square units.
probably.
Like if you just said units or like dots or
Square units
has to be square units.
has to be square units. It's an area, so whatever these units are, they're always square. If that was centimetres, it'd be centimetres square. If that was kilometres, it'd be kilometres square. If that was metres, it'd be metres squared. So square units, whatever those units are. Square because it's area. All right. Another
Sounds pretty hard.
example of this.
over the black with like whiteboard marker and then rub it off.
That's a lot of whiteboard.
That's a lot of whiteboard markers, Zeke. It's worked well with this, hasn't it?
Yeah, it works.
Mr. Sin, I've got a question.
Ta-da!
Kind of
Yes.
How do you decide if you're going to use the left rectangles or right rectangles?
question tells you what to do.
Did this question tell us?
The question would tell you.
Said
Four left
using
rectangles.
So this one said using 4 left
Oh,
rectangles.
I didn't get the left.
Oh, rectangles. Alright, triangles. That's fine.
Yeah, no,
That's
good
why I'm
question. They will tell
confused.
you which ones to use.
I've written it everywhere.
Because it does make a difference.
Yeah.
So yes, you will be told which
I'm gonna
ones.
fell out of that.
Triangles.
That's the highlight going on.
Not very well.
Alright. So, with 1 to 2 of x plus 1 x.
Is that the formula?
That's what we're asked to do. We're asked to find that using an area formula.
Oh, is that a 1? Okay.
1 to 2, yep. 1 to 2. So that means from x equals 1 to x equals 2 of this with that. What does that mean? That means we were looking for some area. So let's have just a quick sketch. See what it means. X plus 1 is a straight line, I believe.
It is
Goes like that. And we're asked from 1 to 2. The integral from 1 to 2 of x plus 1. So what that means is that we're looking for this area in here. Now that area in there is what sort of shape?
It is a rectangle.
It's a rectangle.
It's,
Oh, it's a trapezium.
Trapezium, yeah. So the area
is that
I actually got that right.
is a trapezium. And this is one of those things that's on the
Oh, I don't like.
formula sheet. Half A plus BH.
Oh,
I
yeah.
think you don't even know what a trapezium is.
So the,
Do
yeah,
they have a picture of them on the formula sheet?
yeah, they're on the formula sheet.
No, but like a picture of the
No.
shape.
I can't remember what a trapezium is. now.
Right, so the A and the B are these lengths,
And then the figure then
and the height is this distance. So we need to know these lengths. So when
Well, that's
x equals 1, y would be 1 plus 1.
right.
When x equals 2,
Big 3.
y would be 3. So those lengths A and B are
2
2
and 3.
and 3. So a half of 2 plus 3 times 1 would be 5 over 2 square units. Alright. Nice when the line's a straight line, but it's not always a straight line. So, before we can go any further, what we need to learn is a thing called antidifferentiation.
Not this shitty game.
It's easy.
Yeah, it's just a lot better.
Easy once you know how.
Senate, don't touch the board.
Yeah, please don't.
You can use the bottom half if you want.
Are they up? Right, so is antidifferentiation just backwards differentiation?
Yes.
Very good, Lara.
It's a differentiated thing.
That's easy.
You're
Easy
adding
peasy.
that to.
Can you do it?
Can I touch the board now, Lara?
It wasn't me, it
No,
was just
no,
someone that I
Go on.
won't name.
I think that's
Give me
cool.
some. active
So you'll
in.
be
Shut up.
raising the power?
Yeah,
I would
you
give
can
you
do it
It's
now.
like telling me to go to this shop when we're in the desert.
I'm good.
That is
You can rub it off, but leave the
nothing like
leave
that.
the
There are no resources here.
What am I leaving?
Just rub the whole thing off.
Just write down
leave the
the
equation. I haven't written the equation.
Just-
Yeah.
Rub it off.
Keep the trapezium stuff.
You can get rid of that.
And now rub the stuff.
There's like a whole new topic.
Yes, chapter 11.
Wait, so it's, oh, it is, okay.
Anti-differentiation.
I need to pay.
Now, sometimes you see them written called indefinite integrals.
Should I get another?
Well, thank you, Cameron. I didn't know 2 minus 1 was 1.
Why are you asking a question there?
Makes a valid point, Jay.
I'm dumb, alright?
Just watch out, I'll start getting complaints about the quality of my recordings from all my subscribers. You know,
Don't want to get demonetized.
all 5 of them. All right, anti-differentiation, as people already said, is the reverse process of to differentiation.
So he gets like, off YouTube. Or sends you a little
So, we're going to look at just the polynomial one today, we'll look at others. So, since when you differentiate x to the n, you get n x to the n minus 1. If we reverse that, and the symbol we use to show that it's the reverse is this symbol here, that integral sign of n x to the n minus 1 dx. What are we anti-differentiating with respect to? We're anti-differentiating with respect to the x. Then that means we're going back this way. So that would be x to the n, and then plus c, some constant. Because when we've got this and we're going back to that, we don't know whether there was just a number there or not. And we would need to be given some information to find out what it was. And so we just write plus c on the end, saying there might be some number there. We need information. Now, you're not going to see it written like that on your formula sheet. Usually you're going to see it written as it's on the formula sheet that's in the exam. Normally it's written as x to the n dx, and that would be equal to 1 over n plus 1 x to the n plus 1 plus c. Where n is not equal to -1. Because if n equals -1, it ends up being something completely different altogether. Alright, let's have a look at a couple of examples. Start with a simple one.
How come we suddenly just started using that weird squiggly thing?
That's the separated differentiation.
This, that's right, we've just started doing antidifferentiation.
Is the like the opposite of x to y.
So
So
if
we
I
need-
see that thing, it means antidifferentiate.
That's what it means.
Correct.
Good job, Lara.
Thank you, Steve.
I thought I'd already said that, but perhaps not.
I think I just missed it.
So it just, ddx means differentiate, this means antidifferentiate. All right, so if we're antidifferentiating, this x here has power of,
1,
so it's going to be power of,
2,
then the 3 still there, needs to stay there,
divided by 2.
and divide by
2.
2.
our new power. Plus 4. Now 4 means 4 times x to the what?
1, 2. I'm so confused. 0.
4 times x to the 0, does it not? X to the 0 is 1, 4 times 1, 4. So this now is going to be
4x.
x to the
4x.
x to the 1 over 1, of course, and I don't usually write those things, so I'll just put them there, plus some constant if there is. Right, so
Will
there.
constant always
I
be
have a
C?
question.
Just write C unless you're given information. I'm going to do an example where we're given
Can you
information.
do that whole thing again?
Yeah, can you just run that back and like explain it? Because like when you got to that 4x to the power of 0, I was like,
Right, let me,
You just explain the 4x.
You probably have.
right, let me
No,
just-
I didn't
It's
get
just
where
saying-
the 2 down the bottom.
That's the new power, so you need to put the new power.
Alright, so
You need to divide the kind of new part.
So, if we think about when we differentiate x to the n, or x, let's say differentiate x to the 3, for example. So, what do we do when we differentiate? We bring the old power down and multiply. So, the old power and multiply, and we reduce by 1. So, if we're anti-differentiating, we're going to do the opposite. So, if I'm anti-differentiating 3x, and that's 3x to the 1, I've got to do the opposite. So what's the opposite? The opposite to reducing the power by 1 is increasing the power by 1,
And dividing the x by...
and the opposite of multiplying is dividing. The opposite of multiplying by the old power is dividing by the new power.
Cool.
And then the 4, you think about 4 as being the same as 4 times 1, which is 4 times x to the 0. So when we anti-differentiate that, the 4 stays there,
Increases by 1.
increases by 1, divide by the new power. Does that clarify people's questions?
Yeah.
Explain the 4th in this one.
Oh my god.
4 is 4 times 1.
Yes,
Anything to the 0 is 1.
yes.
So this 4 could be thought of as
4 times x to the
4x to the 0. So when I anti-differentiate 4x to the 0, leave the 4 there, the x, I increase the power by 1, divide by the new power, it's just 4x.
Yeah,
But I'm going to differentiate 4x, you get 4.
Oh, no, because there's no extent. That's...
What is it?
If you differentiate 4x, you just get 4.
Yeah.
You do,
You
correct.
just add the x back.
Yeah.
Yeah. And that's why you can't put in something without x when you.
Right, so I just try to do that to illustrate, because sometimes people go, hey, where did this x appear from? So that's, what's in behind that extra. So you're probably not going to go through that, you're probably just going to go straight from here to here. You're not going to go through all of this.
So is our sack on differentiation and anti-differentiation?
Correct.
When is that that?
Hopefully not week 5.
Tomorrow.
Yeah, it is week 5.
Oh.
Yes.
Friday.
in week 5 though.
No.
What?
Friday.
Yeah.
Tomorrow's a week by 3 days.
My folio's due and
Oh,
what week is this?
yeah, the days.
We're in week 3.
Week 3.
It's not week.
Yeah.
That's unfortunate.
Week 3.
Yeah, it's full Thursday, Friday.
I thought portfolios were just ages ago.
Alright,
One part of them was.
so something like this, for example. Before we can do anything, we need to adjust the root x. We need to adjust the root x to the power of half.
X.
Half, correct.
Wait, what's a root? Oh, root x doing?
You just had to ask, what's the square root?
No, I thought you were saying root x. Like.
Root x. Okay, so following the same thought process.
I hate myself.
Increase the power by 1. Half plus 1.
1.5.
1.5, which is
1.5.
3 over 2. Then what do we need to do? We need to divide by
3 over 2.
the new power, yeah, plus some constant. If we're dividing by a fraction, what do we do?
Times.
And
Times.
flip, good, 2 over 3. 3's cancelled, isn't that nice? And you get 2x to the 3 over 2 plus some constant. Alright, one last example. Sometimes you can find the constant. So if you are given some information about the function, then you can find the constant. So let's have a look. So this one here is our derivative, and we want to find the function.
Is that meant to be x cubed plus 4x cubed?
Marcus or
Let's go for x squared, eh? Shall we?
I think so.
that's
You're nice.
Thank you.
What? Because he has to change the number. It's not that
All right,
hard
so
change
to
it
get
from
our
two.
function, we've got to anti-differentiate our derivative to get back to here. So our function would be the integral of x cubed plus 4x squared dx. All right, I'm going to run out of space down there. Oh no, I'll put it down here. So, x cubed will become
X
x to the
to the
4
4 over 4.
over 4. 4x squared will become
4x cubed over
4x cubed over 3 plus some constant. And so this is then where the f of 0 equals 0 bit comes in. Alright. It could be f of anything equals anything, but in this case we know that f of 0 equals 0. So, what does that mean? Well, f of 0 means stick 0 in for x. And we know that's equal to 0. So in this particular case, C would be 0. Doesn't have to be, but this one is. And so in this particular case, we know that f of x is equal to x to the 4 over 4 plus 4x cubed over 3. All right. So that's it for today. And so this is, and I'll give you the work plan in just 1 second. A and B. I always make you sad, Jed.